Happy Monday, YouTubers. Just a quick informative video for, I say quick, it'll be as quick as I can make it. We're working on Daikin air-source heat pump boilers. Never worked on one of this size before, and I've only ever worked on Daikin Altherma. It's slightly different than the Altherma. It's more like a Mitsubishi EcoDan, but a large version of it. So this is the system we're working on, which is an EWYQ064BA Whiskey November Bravo Hotel. There's two of them down in this plant room. One does cooling, one does heating. So inside you've got water cooled and water heated 4-port coils or fan coils, and the heat inside has failed due to an issue which I'm going to show you now. So if we walk along here, you see Ashley is carefully pulling apart the system to get to the faulty part, which we're going to replace. So this is the cooling circuit. These are your two VRV air source heat pumps, and then on the side, which is almost like a bolt-on, on this side here is your heat exchanger, and on this one, as you can see on the pipes, chilled water. So this is doing the chilled water. So in the summer this will send cold water to the fan coils inside when needed. And then on this side we've got the heating system that says there, heat and return, and this sends hot water. So obviously in the winter, which is now, we've got an issue with the heating system, and the initial problem was A6 fault, which is quite common on these. I've only come across it once before, but the systems are both exactly the same. Yeah, we will drain the water out. The systems are both exactly the same as in what they do. And you need to turn the water off, Ash, at the isolation points. Just hold fire there, Ash, while I'm just doing this. So A6 fault was what came up. Had a look online and on the app, and the fault indicated to either a sensor, a flow switch, or a block filter. So we went through the diagnostics of the flow switches, which are connected to X4M in there, which are a simple open and closed circuit, and we also went through the resistance checks on these two resistors here, which are a flow and return resistor, and they were fine. However, one of the flow switches was permanently open circuit, which was creating the A6 fault. So what we've had to do is order one of these, which is it's a generic part. All the flow switches are the same from Daikin, available I think it was a couple of days turnaround to get that ordered. And then these simply disconnect from X4M, and they're underneath this little lagged bonnet here is your flow switch, and I believe they just unscrew and then screw back in. But on this system, because of the size of it, there's two. So there's one on that side, and there's also one on this side, as you can see. And we figured it out just by pulling the cable back that it was the left hand side which had failed. So now we're going to go through replacing it. Now, to replace it, you need to drain down the heat exchanger side by simply isolating the flow and the return. And because it's flow and return, you need to open the bypass valve, which allows the water to miss our coil and go through the bypass back to the pump. So we've now got isolation here and here. We've got a drain port here, which you can let the water out like that. Water will come out of that eventually. And also, while we're draining the system down, we're going to remove the inline filter, take that out and clean it. It's a job you may as well do while the system's dry, and it doesn't take more than 5 minutes to do it. And that's pretty much it. Once you've done that, you put it all back together and we'll run it up. Fingers crossed it should all be run fine. Happy with that, Ashley?
All happy.
Happy? Oh, just so you know, because we're in a freezing cold plant room, This system runs in cooling. To get a bit of heating, what we've done is we've put the cooling system into test so that we get some warm air off the condensers while we're working out here in the freezing cold. I think Ashley was slightly impressed with that life hack. Yeah, yeah, let's get on with the job, shall we, Ash? Cheers. Okay, we've removed the flow switch. Just so you know, this is what it looks like. All that is a paddle on the end. When that paddle moves left and right through the flow of the water, it makes or breaks or doesn't break the signal. So it is a simple open and closed contact, and to test it while it's in situ, you can just use your multimeter and a continuity tester to test across the terminals from the PCB. I'm not teaching anyone to suck eggs, but that is how you test it. Fairly simple, straightforward continuity test. And when you put it back in, you need to make sure that when you put the new one back in, you need to make sure the arrow is pointing in the correct direction, which is the flow of the water. So the flow is pointing in the same direction, so that when the water flows through it, paddle goes in the right direction. And I think that's about it. It's just putting it back together now, and then we'll run it up. Okay, thanks for watching. Click and subscribe on the link below if you like to see, they're not many, but the odd informative video. I'm only putting these videos up because this is all new systems to me. I am a fridge engineer, but this is the way systems seem to be going, mixing refrigeration cycles with water to create hot water, and I guess you've got to move with the times. Okay, thanks for watching, take care.